Hey guys, how you doing? It's Mr. Chavla, and I'm here to. I just pulled up the wrong pen, not the one for the notepad. I'm so sorry. That was a ultimate blooper. Where did I put it? I got it. I got it. I'm okay. I'm okay. I found it. Okay. This is Mr. Chavla, and today I'm going over the June 2019 Common Core Algebra 2 exam. In the previous video, I went over numbers 1 through 12. In this video, I'm going over numbers 13 to 24, so finishing up the multiple choice portion. Um, Again, it's Mr. Chavla or Mr. C. Okay, so let's get started with question number 13. Okay, make this a little smaller so we can read this, okay? And I'm going to pull out the highlighter tool. And I need to reconnect to the internet because it just turned off. Okay, so I'm going to pull out the highlighter tool. A group of students was trying to determine the proportion of candies in a bag that are blue. So they want to know what proportion is blue. The company claims that 24% of the candies in the bag are blue. So the students want to know what proportion of the candies in a bag are blue, and the company claims that 24% of the um, candies in their bags, in any of their bags, is blue. So the students ran a simulation 100 times with a sample size of 50 based on the premise that the company was being honest and 24% of the candies are blue. The approximately normal results, was a normal distribution of the simulation, are shown in the dot plot below. So guys, what we want to understand is in this dot plot, each of these dots represents a sample size 50, and they're telling what proportion are blue, right? So in one of the simulations in the computer, uh, in this one, 10% were blue. That only happened once. And in this extreme, 40% was blue, and in this one, it was something more than 40%, right? But if you check, most of them are between 20 and 30, right? Most of the time, between 20 and 30% are blue because they were using the premise that 24% are blue. But let's continue. The simulation results in a mean of 0.254, meaning the mean of all the proportions, right, is 0.254. That mean also means average, and a standard deviation of 0.60. Based on the simulation, what's the plausible interval containing the middle 95% of the data? Guys, so this was, remember they said normal distribution? In a normal distribution, 95%, the middle 95% of data is always the mean minus 2 standard deviations to the mean plus 2 standard deviations. So we're gonna write it out. So mean plus and minus 2 standard deviations, where the mean is 0.254 or 0.254, which is pretty close to the 24% that was claimed, right? So that's to be expected. Plus and minus 2 times 0.060. And I'm just going to use the calculator to get that real quickly. All right, let's reset this. I'm going to reset this. And let's take a look and see what we get. So it was 0.254 plus. So as I type, the answers are going to pop on the right-hand side of the screen. So, and I want to put the lower, and let's get the lower value, minus 2 times 0.060. It's 0.134. So it should be from 0.134 to 0.374. So that is, we're 95% confident that that the results should be somewhere in this range whenever we do a simulation. 95% of the time, the results will fall somewhere in that range of 0.134 to 0.374. All right? So our answer is choice 2. This is about normal distributions and the 95% confidence interval or 95% confidence level, okay, based on standard deviation from the distance from the mean being 2 standard deviations below and above the mean is a 95% confidence level, okay? So that was question 13. Pause the video if you need to. I'm trying to just keep myself out of the way here. All right, that's the best I could do, guys, without. Okay, But I'm going to move on to question number 14 now, okay? Selected values for the functions, I keep picking up the wrong pen. That wouldn't work if I try to use it here. So selected values for the functions f and g are shown in the tables below. So this is f of x, and here we have g of x. All right. A solution to the equation f of x equals g of x is, so if we want, I'll use blue for f of x, guys. A solution to the equation f of x equals g of x. So guys, when we have f of x equals g of x, when two functions are equal to each other, they're just asking for the x value. So which x value makes f of x equals g of x? They're basically saying when x equals what? So let's take a look at the choices one by one. So when x equals 0, when x equals 0, f of 0 is -6, g of 0 is not. So that's out. 2.53 I don't see anywhere in the x column, so that's out. 3.01 I don't see anywhere in the x column, so that's out. By elimination, it has to be 8.52. F of 8.52 is 2.53. G of 8.52 is also 2.53. So x equals 8.52 is our solution. That's when f of x is equal to g of x, when choice 4, when x equals 8.52, okay? So it's always the x coordinate whenever they're talking about function notation, f of x equals g of x, all right? That was not a bad question. The only trick is you need to understand it's the x value they're looking for, okay? Next question. The expression 6 minus that whole thing, 3x minus 2i squared, is equivalent to, I will do this by hand, and I'm going to use some space here. So 6 minus 3x minus 2i squared becomes 3x minus 2i times 3x minus 2i. I'm going to keep these in brackets so that we make sure that this stays separate, right? So if I distribute the 3x, I get 9x squared, see I have to remember to keep the parentheses, minus 6xi. Then I distribute -2, and I get -6xi again, plus 4i squared. I'm going to keep bringing down the 6, and I get 6 minus 9x squared. These two terms, -6xi minus 6xi is -12xi, plus 4i squared is -1. So this becomes finally 6 minus, I'll start distributing the parentheses, minus 9x squared plus 12xi. And let's actually change this, guys. I'm not going to distribute yet because I want to simplify first. Otherwise, it's going to mess things up a little bit. So 6 minus, in parentheses, 9x squared minus 12xi, and 4 times -1 is -4. Now, this becomes 6 minus 9x squared as I distribute the negative sign, right, or -1, plus 12xi, plus 4, but I'll just put the 4 plus here. And then in standard form, so this becomes 10, you get 9x squared, -9x squared, plus 12xi, plus 10 should be our final answer. So -9x squared, plus 12xi, plus 10. Choice 1. -9x squared, plus 12xi, plus 10. Okay? Pause the video if you need to. That was a question, just being careful with your operations and knowing how to work with complex numbers, right? Now we're going to go to number 16. A number, we'll call it x, minus 20 times its reciprocal. So guys, if you put x, that's the same as x over 1. The reciprocal, you flip the fraction, it's 1 over x, right? So minus 20 times its reciprocal, which will be 1 over x, equals 8. What's the number? Okay, so what we're going to do now is we're going to use our calculator since it's multiple choice and get our answer quickly. And I'm going to input the values one by one. So x is equal to, so in choice 1, x equals 10 minus 20. So, and I'll substitute right there. I end up getting 8 if you see right here. So x equals 10 is a solution. So I'm going to write that part down. Doesn't mean our answer is choice 1. So we know one of our answers is x equals 10. These two don't have that as an option, so we're down to 50-50. Now all I'm going to do is I'm going to substitute -2 for x instead. So let's try that. -2 minus 20, not equals, minus 20 times 1 over -2 also gives us 8. So our answer is x equals 10 and x equals -2. So our answer is choice 1, just like that, guys. The calculator is really useful, and let's just make sure it doesn't work for, let's say, when x is +2, because I want to make sure we eliminate that choice. Yeah, when it's +2, we get -8, so that doesn't work. Our answer is choice 1. Now, if you wanted to do that by hand, I'm going to show you how to do that now, okay? I'll go to the smartboard, and our original equation, I'm going to minimize me. I'm going to use as much of the screen as I can. All right. Our original equation was x minus 20 times 1 over x equals 8. I'm going to change this to x over 1. And then if I multiply the 20 by 1, I get 20 over x, and it's equal to 8 over 1. Now in this form, you could tell remember, no denominator can be 0, so x cannot equal 0. You always want to make sure you eliminate that choice so that if you get it as an answer, you have to reject it and not include it in the solution set. Now what I want to do is I want to make all the denominators equal. So only thing that's missing, guys, is if I multiply by x here, if I make all the denominators equal to x, they'll all be the same. So if all I have to do is multiply this by x, I got x here. X, x. I don't need to put the 1 because multiplying by 1 doesn't do anything. I could put the 1 multiplied by 1 here. So basically my equation now it becomes x squared. I don't over 1x minus 20 over 1x equals 8x over 1x. When the denominators are the same, you don't need them anymore. So what it changes to is now just the numerators. X squared minus 20 equals 8x. I'll subtract 8x on both sides and get x squared minus 8x minus 20 equals 0. I want to factor by looking for two numbers that are going to multiply to -20 and add to -8. And that's 2 minus 10 will give you -8. So x plus 2 and x minus 10 equals 0. If you solve, x plus 2 equals 0. X equals -2 is the solution. X minus 10 equals 0. X equals 10 is your other solution. Sorry about this mess. If I did it correctly, the only thing to watch out for is factoring. 2 minus 10 is -8. 2 times -10 is -20. And x plus 2 gives us a root of -2. X minus 10 gives us a root of +10. And neither of those was equal to 0. So -2 and 10, let's see if we got the same thing. -2 and 10. So that was algebraically not so bad either, okay? Pause and rewind the video if you need to. I'm moving on to number 17. And I'm going to keep me minimized so that we could fit stuff so I could write on the side, okay? Or I'll move myself over here, and if I need to move out of the way, I'll move out of the way, and I'll keep myself here for now. So let's pull out the highlighter. A savings account S has an initial value of $50. The account grows at a 2% interest rate compounded n times per year, and t is the number of years according to this function below. S of t equals 50 times 1 plus 0.02 over n to the nt. This is just compound interest, guys. The amount is simply equal to the interest rate. R is equal to 0.02. That's the annual interest rate. N is the number of compounds per year. So the formula is always and 50 is the initial amount. So it's always going to be S of t equals initial amount 50 times 1 plus r over n to the n times t, where t is years. But r is equal to 0.02, so that's how we get 50 is the initial amount. 1 plus 0.02 over n to the nt. All right, that's where the formula came from, which you should know that anyway because they're not always going to give it to you. They were very generous to do that. But let's look at the next part. As n increases, which statement about the account is correct? So they want to know which one's correct. So as the value of n increases, the amount of interest per year decreases. That seems like it would have been correct, right? Because you're thinking, okay, so if n increases, then the value of 1 plus 0.02 over n has to decrease. But because we're multiplying, we're raising to the nt power, that n is also in the exponent. If you're raising to a higher power, the amount of interest will actually increase. That's what's known as the effective interest rate. the more frequently you compound, the higher the actual interest rate. The actual or effective annual rate increases. There's more interest the more frequently you compound. If you compound once a month, let me minimize me. I knew this would come. If we compound once a month, it'll be faster. The interest will go faster than if we compound once a year. So let's just try this real quick. So I'll go to the graphing calculator, and let's just say s of x is equal to, all I need to do, guys, actually is find, let's write this out, 1 plus 0.02 over x, because I can't use n. Here's what I'll do. I'm going to use, let's say that it's once per year, so n equals 1, and it'll be to the 1x, right? And then let's do another one. So I'll call this s1. s2 of x, let's say it's done now instead twice a year. Not even, that was one time a year, right? Let's say it's done quarterly. That means 4 times a year, right? Or every 4 months. So it'll be to the 4x. Let's compare these two first, and let's see which one grows faster. The initial amount will be the same at $50, right? Excuse me, hiccups. So s1 of x, s2 of x, and all we need is our input. So they start at 0, right? After a year, which one grew faster? The one that was compounded 4 times a year, a little bit faster, not a lot. After 2 years, after 2 years, because x is years, right? The second one grew, and it's beginning to show a little more, right? Not a lot more, but a little bit. After 3 years, you see that the second one is greater, right? 4, 5. Let's say now we increase, I'm going to actually take this and increase to 10 years. Now we're going to see some more, right? But the one with more interest is when the value of n increases, right? So let's say we add another one, s3 of x, and let's say this one's once a month. That means it's n equals 12, because once a month is 12 times a year. And let's put this one, and you'll see that the growth is even faster for that one. So the initial amount's the same. The second, after a year, s3 of x is greater than the other two. After 2 years, 3 years, see, and the more time passes, the more you'll see the difference becomes more significant. Not a lot, apparently, right? You make $362.23 total after 100 years with the first option. That was once a year. Option 2, 4 times a year, you make $367.62. But with option 3, you make $368.84. So the truth is that as the value of n increases, the amount of interest also increases. This is known as the effective interest rate. There were other ways to show that, but that was the way I thought would be easiest to see. So choice 1 is not correct, so that's out. I'm going to just scribble it out, okay? Because the amount of interest per year actually increases. Next one, as the value of n increases, so this is as the value of n increases again, the value of the account approaches this function. You're probably wondering you might be wondering, I shouldn't say probably, some of you might be wondering, what is that? If you remember, n is the number of compounds per year. If I compound once a year, that's n equals 1. If I compound once a month, 4 times a year, that's quarterly, n equals 4. So this is annually, once a year. This is quarterly, 4 times a year. Monthly means 12 times a year, since it's 12 months in a year. So if you compound every month, you'll end up compounding 12 times in a year. So if we compound more frequently, let's say you compound daily, you're going to get n equals 365, right? If you compound twice a day, you'll get n equals 2 times 365, right? Eventually, you could be compounding every hour, every minute, every second, and we get to a point where it's like, okay, you're just going to compound like every split second, like at every moment in time. That's where we get the continuous interest. So this is daily, which I don't think I've ever seen. But if it's continuous, meaning at all moments in time, meaning like more than once a second, the formula becomes like this. S of t is equal to the initial amount, we'll call that p for principal, times the natural number e to the rt. So if we do this, S of t is equal to the initial amount is 50 times e to the interest rate as a decimal is 0.02 t. This is true. Our answer is choice 2. All right, you just have to be a little careful with this and know the difference between effective rate and nominal rate, which is just the rate that they advertise as, right? Because the effective rate is not the same, meaning that the actual interest rate is not 2% per year when it's compounded quarterly, monthly, or daily, okay? Now, if we look at the choice 3 is saying that as the value of n decreases to 1, the amount of interest per year increases. That's just saying the same thing as option 1. As the value of n increases, the amount of interest increases. But as the value of n decreases, the amount of interest will decrease. So 3 is out. So as n decreases, the amount of interest per year also decreases. Now, choice 4, as the value of n decreases to 1, the value of the count approaches the function. So this, guys, if you look, if I replace t with 1, if it's compounded annually, you don't have to worry about, and I'll use the blue marker for this one, all right? Or blue pen. You don't have to worry about the actual formula. It's just regular exponential growth. Because if it's once per year, it'll be s of t, sorry, that's a t, 50 times 1 plus 0.02 over 1. Let me fix that, guys. I know I made a mess. Let's write that nice and neat where we can see, okay? It'll become s of t equals 50 times 1 plus 0.02. If n equals 1, it'll be over 1 to the 1 times t. That becomes s of t equals 50 times 1 plus 0.02 divided by 1 is just 0.02. 1 times t is just t. So this should have been plus. So this is wrong. And our answer is choice 2, okay? We're almost there. Now we're going to go on to number 18. This is about compound interest. If you know about compound interest and continuous interest, eMath instruction has like one of the best lessons I've ever seen on that, all right? The Algebra 2 curriculum, Common Core, so check it out. Number 18. There are 400 students in the senior class at Oak Creek High School. So 400 is the total number of students in the senior class at Oak Creek High. All of these students took the SAT. So all 400 students took the SAT. The distribution of their SAT scores is approximately normal. So we have another normal distribution. The number of students who scored within 2 standard deviations of the mean is approximately, so guys, in a normal distribution, 95% are within, just like in the previous, one of the previous questions, right? I don't know if it was from this video or an earlier video, but it was on this exam. 95% are always within 2 standard deviations of the mean. So if it's 400 students, we want to take 95% of 400. 0.95 times 400, which we'll just do very quickly, or 400 times 0.95 is 380. Okay, so it's 380. That was a giveaway if you know about your normal distribution. Okay, now number 19 is another multiple choice, so I'm going to use the calculator to get this quickly. And I'm going to change it so that it says x, because we're going to use x instead of b, all right? So x equals square root of 2x squared minus 64. So which values when I substitute for x doesn't change when I substitute in here? So let's just use the calculator, and then we'll also do it by hand. So we'll clear this out. We'll clear this out. We'll clear everything out. Okay. And one of them is just, we'll set it so that y1 equals x. That's just the original input, right? B, in other words. And the other one we'll set equal to the square root of 2x squared minus 64. And we want to see for which x values do they end up being the same. So I'm going to put a table in here. You could also look for the intersection point of the graph, but I don't know how big that's going to get. Well, shouldn't get too big. y1, y2, and let's just use the numbers that they give us. -8. So y1 equals x. So y1 obviously is going to be the same as what x is, but y2, the square root expression, is equal to +8. So choice 1 is out. All right. Choice 2, +8. That's a possibility. So this one is a possibility. This says plus and minus 8 because of the negative 8 didn't work, and it's not the empty set because x equals 8 worked, or b equals 8 is our solution, all right? Now, to do it by hand, all right? So you could move on. There's nothing wrong with doing this in the calculator, moving on. But in case this showed up and you had to do it by hand, or you wanted to know how to do it by hand, here's how it goes. We take the original equation, b equals square root of 2b squared minus 64. And how do we get rid of the square root? We square both sides. That eliminates the square root symbol. So our new equation becomes b squared, we don't need the parentheses, equals, without the square root or square, 2b squared minus 64. Now what I'm actually going to do is I'm going to subtract b squared on both sides, which is 1b squared, right? This side becomes 0. And 2 minus 1 is 1b squared, just b squared minus 64 equals 0. I'm sorry, there's a bug in my face. Mosquito. Sorry. So now we could solve this either by factoring or completing the square. Let's just factor b minus 8 and b plus 8. If b minus 8 is 0, you get b equals 8. b plus 8 equals 0, you get b equals negative 8. But then you see that if we were to substitute into the original equation, so if b equals 8, we get 8 from b, right? Equals square root of 2 times 8 squared minus 64. 8 is equal to, if you enter this expression in your calculator, it'll become 64, the whole thing. Then you get 8 equals 8, and b equals 8 does check out. But if you put b equals negative 8, what's going to end up happening is you get negative 8 equals square root of 2 times negative 8 squared minus 64. If you square the negative 8, it becomes positive 64. 2 times 64 is 128, minus 64 is 64 again. Now, it doesn't have a plus minus sign. If this had a negative sign in front, then negative 8 would have been the solution. But the square root of 64, just like that, is 8. It's not the same as if I said this or this, right? This is equal to plus minus 8. This is equal to negative 8, and that's a 64, right? But if it just says square root of 64, that's 8. All right, because square roots are not negative unless there's a negative sign in front of it. Okay, so this is not true, so this is an extraneous root. That's why negative 8 does not work. And our answer is choice 2. Okay, so we're going to move on to number 20 now. And we could pull me up for a while at least. So which equation represents an exponential relationship? So exponential, guys, just like in a geometric sequence, there has to be a common ratio, a constant multiplication over equal intervals of x. So let's look at this real carefully. The x values are increasing by a constant amount of plus 1. That's important when looking at this, guys. So 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, 5. Okay, now are we multiplying? 8 divided by 2 is 4. 4 divided by 2 is 2. Divided by 2 is 1. Divided by 2 is a half. Dividing by 2 is the same as multiplying by a half. That's exponential. That was awesome because the first one was our answer. If we look at the next one, the x values are going down 4 each time. So it's a minus 4 pattern. But the y values are going up 1. This is called a constant rate of change. When we have equal difference over equal intervals, that's linear because it has a constant rate of change or slope. So that's not our answer, right? This one, if you look, you can't multiply 0 by anything to get 1. But if you look carefully, guys, it doesn't have a common difference. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. So this is just quadratic, where y equals x squared. It's quadratic, just the parent basic quadratic function. And if we look at this one, again, 1 times 8 is 8, but 8 times 8 is not 27, so that's not exponential. If you look at this carefully, 1 to the third power is 1. 2 to the third power is 8, because 2 times 2 is 4 times 2, 8. 3 cubed is 27. 4 cubed, 5 cubed. This becomes y equals x cubed. That's known as a cubic. So that's not exponential, because exponential has to have x in the exponent. The equation for this one will be y equals 16 times 1/2 to the x, because our y-intercept, if we started at 0, you'd multiply by 2 to go backwards, and half of 16 is how you get 8, and that's the y-intercept. 16 times 1/2 to the x. All right, that's an exponential function when x is an exponent. But without even doing that, just seeing the common ratio, Our answer's choice 1. And then I just showed you guys the other way, just so you understood. But you see the ratio, answer's choice 1, you're ready to move on. Okay, now, a sketch of r of x shown below. If you remembered an earlier question, because they're saying what could be an equation of r of x, remember they were saying in one of the questions, it was saying x minus 1 is a factor, then p of 1 has to equal 0. I'll even show you which question that was. I don't think it was from this video. I think it was from an earlier video for the first section of this, for one of the earlier questions in this section. Here we go. It was saying that it's a factor because p of 1 equals 0. That means that x minus 1 is a factor of p of x. That's also, if p of 1 is 0, that's an x-intercept where y equals 0. Okay, so we're going to look at the x-intercepts to help us get the equation. Okay, so we're going to get the factors based on the zeros or the roots where it's equal to 0. So I'm going to use a blue or red, blue. I like blue, my favorite color. Okay, our zeros are x equals negative c, x equals negative b. I'm minimizing me for now. And x equals positive a. Now what you have to be careful of, guys, is there's 1, 2, 3 turning points, so it's a degree 4 polynomial, which means we should have 4 zeros. If you see here, negative c is one of the turning points. When that happens, there are 2 roots. This has a multiplicity 2. So we have negative c twice. So the factors will be x plus c, x plus c, x plus b, and x minus a, because they have the opposite sign. Because if x minus a equals 0, that's how I add a and get x equals a. If x plus b equals 0, that's how I subtract b and get x equals negative b, all right? So those are the factors. Now let's see what they put in the answer choices, because they're asking for an equation. And it could be something like that, right? It might not be exact. Okay, but our equation should look something like that. All right, and it's important to recognize the turning point. Okay, so the first choice is out because nothing is being squared. That was like the trap, right? This looks like it would have been the right choice. And if I put it in alphabetical order, it looks like this: x minus a, x plus b, and since we have 2 of the x plus c's, it'll be x plus c squared. So this is wrong simply because of that. Otherwise, it would have been right, but because of this turning point, all right? X plus a, out. X plus a, out. By elimination, it's 4. X minus a, x plus b. So we got x plus b. So x minus a, x plus b, and then x plus c raised to the second power. All right, our answer is choice 4. You just have to be really careful understanding that when there's a turning point at a 0, that's called multiplicity. That means that root occurs twice. Just like if I have a quadratic, let's say that the root was 1, and let's say this y-intercept is 1. This one is y equals x minus 1 squared, because the turning point's there. It only has one real root, which, okay? Now we're going to move on to the next question. Question number 22. We're almost there. The temperature in degrees Fahrenheit, let me make sure we answered it. It asked for the equation, and we got the equation. Okay, good. So question 22, the temperature in degrees Fahrenheit in Times Square during a day in August can be predicted by the function t of x is equal to 8 sine blah blah blah. So it's a sine function. T of x is the temperature in degrees Fahrenheit, and x is the number of hours after midnight. So we got to be careful about that. X is the number of hours after 12 a.m. According to this model, the predicted temperature, and let me come up here too. According to this model, the predicted temperature to the nearest degree Fahrenheit at 7 p.m. is, so what we got to be careful is we don't just substitute 7 for x, because it's like, okay, after midnight. What we got to watch out for is 12 a.m. is midnight, right? That's when x equals 0. That's the starting time. If we go to 7 a.m., that's 7 hours. All right, we pass another 12 hours from 7 a.m. to 7 p.m. And then that's 12 more hours, so that becomes x equals 19, because 12 additional hours have passed here. All right, this is 7 hours plus 12 hours is 19 hours. Or you go from 7 a.m. to 12 p.m. noon, that's 5 hours plus 7 more hours, and you could get 12 hours like that, right? But either way, the total number of hours after midnight is 19. That's the first thing. Next thing, you want to make sure that your calculator is in radian mode. All right? So, and then we're just going to find t of 19. So t of 19, and we're going to just enter it in the calculator, okay? So I'm going to go here, minimize me for now, clear everything out, make sure it's in radian mode. You see how here it says it's in degree mode? This says degree mode. I need it to be in radian mode. So I'm going to switch it. And I'm going to just enter my internet disconnected again. I don't know why that keeps happening. Okay, so radian mode. And I'm going to want to find 8 times sine. You can't probably type it like that in your own calculator. Or why not just go to the graphing calculator? All right, and we could just enter t of x. And I'll enter the equation here. 8, and I don't want any of this yet. And you'll see why in a second. I don't want to put anything in yet. 8 sine 0.3x minus 3 plus 74. Now keep in mind, you might not be able to put function notation in your calculator. The other thing I want to watch out for, guys, is the setting in my calculator. I need the setting. I want to make sure it's in radian mode. I don't know. Here, see, this would be degrees. This is radians. I got to make sure it's in radians. I won't worry about the graph for now, but I do want to know about the values. So now I'm going to enter 0, 19 is 77.4 degrees to the nearest tenth, or 77 degrees to the nearest whole number. So to the nearest degree, it's 77 degrees Fahrenheit, okay? Degrees Fahrenheit. They said to the nearest degree Fahrenheit, so there we go. All right, and that's what you got to watch out for, just that x equals 19. You're using x equals 19 and radian mode in your calculator, then you'd be good to go. All right, now number 23, consider the system of equations below. Now, there should be some kind of system of equation solver, even with 3 variables in your calculator. I don't know which kind you're using. If you're in Casio, you use simultaneous equation solver with 3 unknowns. I don't know how the other ones work. I'm going to go ahead and do this by hand. And then we'll see if I could find something online. I would highly recommend just use the calculator for this one and move on. Let's use the calculator, right? Because I think all calculators should have it. So system of equations solver, 3 variables. In the Casio, what's great about it is you could use any number you want to. Like you could go to 4, maybe even 5 unknowns. I never use more than 3, but let's try this out. So in the system of equation solver, you just enter the coefficients and the constant at the end. But in this one, you actually type in the equations. What happened? Okay, this clearly isn't the way to do it. This is not good. I'm just going to do it by hand, guys. I don't know which one to use in the online. So what I'm going to do is I'll do it on my calculator that we use at my school, and then I'm going to do, but after I do it by hand, okay? And then I'll show you guys how it works in the calculator in my school. And I definitely need a lot of space here. So I'll call this equation A, B, and C. So I'm going to add equation A, because we're going to eliminate the x this way. I'm going to add equation A to equation C. So we have negative x plus 4y minus z equals 17. So if I add down, x minus x cancels. Y plus 4y, or 1y plus 4y is positive 5y. This becomes negative 2z. 6 plus 17 is 23. Now I want to eliminate, I'm going to multiply equation C by 2 and then add B and C, right? So equation C, if I multiply by 2 on both sides, right, every term is going to be multiplied by 2, including the 17, right? So the entire equation is multiplied by 2. I'm sorry, let me move this. And of course, if you have the calculator and you know how to use that, you won't have to do the work for this one, which is beautiful because who wants to do it when you don't have to? Negative 2x plus 8y, because we're just multiplying by 2, minus 2z, and remember to multiply the second term is 34. And the original one here, and I'll keep this in red, this one just stays here, 2x minus 3y plus 2z equals negative 19. Right, it's plus 2z. The two x's cancel out, which is what we wanted. Negative 3y plus 8y is 5y. And we're in luck because not only do the x terms, but the z terms also cancel out. Usually that doesn't happen. Negative 19 plus 34, if you put in the calculator, is 15. Divide by 5 on both sides, you get y equals 3. Now they're saying which number is not the value of any variable in the solution. So this is our y value, so this is not what we're going to pick because we want to know which one's not a value of any variable. Now, what I'm going to do is I'm going to substitute into the 5y minus 2z equals 23. So 5y minus 2z equals 23, y equals 3. 5 times 3 minus 2z equals 23. But we already had that 5y equals 15, so I could have just substituted 15 for 5y, but 5 times 3 is 15, minus 2z equals 23. I'm going to subtract 15 on both sides. Negative 2z equals 8. Divide by negative 2, you get z equals negative 4. So this is our z value. So this is out, and we're down to 50-50. I'm going to use the original equation, the equation A, x plus y minus z equals 6 to solve for x. So x plus y is 3, minus z is negative 4. So I got to be careful to include minus parentheses negative equals 6. 3 minus negative 4 is the same as 3 plus 4. So that becomes x plus 7 equals 6. Minus 7, you get x equals negative 1. So this is our x value, and our answer is choice 2. The number 2 is not a value of any variable in the solution. Now I'm going to be right back, and I'm going to pop up on the screen to show you guys the number, how to use the calculator. Okay, so pause the video because I'm about to erase everything. Okay, so guys, I don't know if you'll be able to see me at the same time because I really want you to be able to see the calculator. Pause the video if you need to. I'm about to erase everything. And I'm going to show you guys how to use the calculator to quickly get the solutions, at least from the Casio FX9860G2. I'd highly recommend that calculator. It's one of the best ones, I think, for Common Core Algebra and Algebra 2. Okay, so we don't need, watch how quick and easy this is, guys. So I have my calculator right here. It's the Casio FX, where does it say? FX9860 G2. So I'm going to go here to menu. Am I not pushing it? Oh, that's not menu. Menu's over here. Here's the menu button right here. Right? If you're using this model, then you go to EQUA, equation. Now I'm going to go to simultaneous. That's what you use to solve linear systems. And it says F1 for simultaneous. The number of unknowns is 3, and that's for F2. Now we enter, it's a matrix we have down here, which says AX plus BY plus CZ equals DN. So I'm just going to enter the coefficients that I see in the X, Y, and Z. So in the first equation, right, first line, I hope this is visible, guys. I'm going to make this a little bigger, okay? And so here's what we got. So the coefficient of X is 1 in the first equation. Then the coefficient, I'm going to hit execute, enter, which is right down here. I have to make this bigger to show the whole calculator, or I have to do something else. Okay, I'm trying to make sure everything shows. Okay, so I'll pull it back a little bit. The next coefficient is 1 for y. So I'm going to enter 1. And I'm going to hit execute again. And it's a lot faster to actually do it. It's just a little hard to do it here because I don't have an app in the screen. So I enter -1. Then I enter what it's equal to and make sure that all the equations are in x, y, and z form with x, y, z coming first. And then I enter the 6. And I keep hitting execute. And then I repeat for the next equation. So the second equation, I enter 2 for the next coefficient. Then I enter -3. And I got to be careful of the signs. Then I enter 2. Then I enter -19. So this is the matrix so far. Then the next coefficient is -1 for x, 4 for y, -1 for z, and then 17. And if I did everything correctly, I should get the 3 answers. So x is equal to -1, y is equal to 3, and z is equal to -4. None of the answers were equal, so that eliminates choices. The choices that are eliminated then, so we got -1, 3, and 4, okay? And this is a great calculator. I highly recommend it. I'm about to take it away, okay? And let me make this screen a little smaller so we could come back to the exam. And see how that it's a lot quicker when you know how to do it. Like, I know I might have taken a little while because it's kind of cumbersome for me to show the calculator. I never did that before, by the way. Like, when I teach in the school, we have a big screen, a smartboard that I just project. The calculator's installed in there, so I project it there. So it's a lot easier, but I don't have that luxury right now. Maybe I should get it, right? Um, but I love that calculator. And so we have, I'm just going to write down the values we got x equals 1, y equals 3, and z equals -4. You could literally get the solution in under 30 seconds. I would recommend take a little time, take a minute or two. I know it took a little long again because it was cumbersome for me to do it on the screen like that, but literally we could get it within 30 seconds, certainly within 2 minutes, right? And they say which one's not a value, so I'm sorry, x equals -1. X equals -1, y equals 3, z equals -4. So this is x, this is y, this is z. All right, and this is not a solution, okay? Now we're going to go on to the last problem, the last multiple choice, okay? Let's do it. Cameron puts, I love this question. You're probably like, are you crazy, Mr. C? But you'll see what I mean. I hated it in the beginning, but when you get used to it, it's awesome. So Cameron puts $100 into a savings account that earns 6% annually. Again, annually means once a year. So we know what function it should be, guys, right? For exponential growth, we know it's going to be 400 times 1 plus 0.06 or 1.06 to the t. Right here is the amount Cameron, that's why they use C, earns. So that's where the equation comes from. I'm going to write it down so we could see it, okay? The amount of her in her account can be modeled by C of t equals 400 times 1.06 to the t. That's how we get the initial amount times 1 plus 0.06, which is 6% of the decimal, to the t years. All right, that's what they said. So the amount of account can be modeled by the C of t, where t is the time in years. Which expression best approximates the amount of money in her account using the weekly growth rate? So, and I'm going to actually take that and use yellow. So these are very simple questions to solve once you learn how to manipulate exponents. Okay, we want to write in terms of the weekly growth rate. The one thing you want to know is that there are about 52 weeks in a year. So here's how it's going to look like. I'm going to write it over here. So 1 year equals 52 weeks. And they did not change the variable t, right? So what that means, guys, is that if I want it in terms of for each week, I divide by 52 so that it's for 1 week. So 1 week is equal to 1 over 52 years. So that's because, of course, a week is less than a year, right? So that means, guys, if I wanted to do it for 2 years, right, using this equation, I would raise 1.06 to the second power to get the amount after 2 years. The first power for 1 year, 10th power for 10 years, right? But if it's for a week, I'm only going to raise it to a little 1 over 52 power. If it was for half a year, right, that's 6 months, I would raise to the 1 over 2. If I want for a month, that's 1/12 of a year, t equals 1/12. But in 1 week, I just raised to the 1 over 52 power. So C of t, see how we did not change the variable t? They want to the equation should be equivalent to this, or approximately. So it starts with 400, that's not going to change. But in parentheses, I want 1.06. What power do I raise it to in a week? To the 1 over 52 power. Now, if it was w for weeks, I could put w in the exponent. But we're using t. Now, the growth factor was 1.06. That's just what I multiply by each time. But the function should not change if I'm using t as my exponent, because it still wants it to be accurate for the number of years. And this is the weekly growth factor, right? So what I have to do to keep them equivalent, what do I have to raise to in order to get rid of this 1 over 52 exponent? The 52 power. Because if I multiply 1 over 52 by 52, I get 1. And once you get used to that, like the process becomes a lot faster, because it's like, okay, I raise to the 1 over 52 each week, and to make up for that, I have to raise it to the 52 power so that it's still, in terms of the number of years, so that the overall growth factor is still 1.06. Then I'm going to take 1.06 raised to the 1 over 52 power, or the 52 root. So 1.06 to the, minimize me, 1 over 52 power. I had to put parentheses here so that they understand that I want the whole fraction of the exponent. 1.0011211184. And it should be to the 52t. So the first two choices are out, guys, because if you look, these two numbers, they're not equivalent to the original function. If it was w, yeah, it could work, but it has to be the same function if you're raising to the t power. So since these are not equal, that can't work. But to the 52 power, so 1.0011211184 to the 52t. That's choice 4, okay? Because this is equal to that whole fraction right there. That's a lot of decimals. A lot of digits after the decimal. So this, and if we take this farther, right, guys? Remember, if we're using the yearly growth factor, it's raised to the 1 over 52 each week, right? Now, if this is the weekly growth factor, right, the initial amount's 400, what power do we have to read if this is the amount we multiply per week? And there are 52 weeks in a year, we have to raise this to the 52 power each year. That's where it becomes 52t, okay? So our answer is choice 4. And that problem could be done very quickly once you get the hang of it. But if not, I understand it's a very challenging one in the beginning. Let me come over here. I'm going to minimize, not minimize, but make the screen a little smaller so there's room for me too. Because I don't like hanging out down there. I get like all squished down there and it's uncomfortable. Anyway, I hope this was useful, guys. If you enjoyed, please hit like, subscribe. I'd appreciate that very much. It helps me out, and I'll keep these videos coming. If this worked for you, or if there's something you were not clear about, anything, guys. What I'm trying to say, so you have any questions, feel free to ask me in the comment section. If you have anything that you want me to explain differently, there were different ways I could have done any one of these problems for the most part. Ask and you shall receive. If there is something that you're concerned about, something that you would like me to do differently, let me know. If you have any feedback for me, I would very much appreciate it, okay? And I wish you the best of luck. If you're taking the Regents soon, like the August 2019, I know it's coming up because it's July 2019 today. Best of luck, all right? Do the best you can. Take care. Bye for now.